All right, so you're ready to do your 2D Motion Lab write-up. I'd really recommend getting it in a little early, say a few days, a few weeks early, so I can correct it, give you some feedback, you can make revisions, turn it back in, and get a great understanding and a great grade on it. So, what I'm going to talk about today is some of the finer points of how you're going to talk about your results and your conclusion. So I have 3 examples of some types of data your group might have. Your group might have a data set that looks like 1, 2, 3, 4, something like that. And so I'm going to talk about what are we going to do with that data. So when we look at our percent error that we're going to calculate here, that is between your average value and the average of your dots. I've indicated the average of each of these groups with a dot with a line through it. And so in this case, the percent error will be negative because the dot is short. And that's all the negative tells us, just like in physics. Negatives tell us direction. This one's definitely short. This one's just a little bit long, and this one is long as well. So I don't want you to tell me if it's good or bad. Okay? You're going to tell me what your percent error is. I don't want you to say, hey, we had an awesome percent error. We had a terrible percent error. No. We want to focus on what could have caused your error. We don't know if it did. These are just possibilities. We're just at that phase where we're starting to think about what could have affected our lab. And when you come up with something that could have affected your lab, I really want you to link what that is to your results. You've got to connect those 2 pieces of information for me. How did this cause your data? Walk me through the steps. All right, so let's do a couple together. So we got group 2 here, landing significantly short, outside of the range. What does this mean for me? This means that it's landing so short. What could have caused it to land short? Okay, so everyone says friction, air resistance. All right, it's a possibility. It could have caused your data. Air resistance causing this much of a difference? There's got to be something else. If you're going to tell me it's friction or air resistance, you better give me 2 things. I'm looking for something else. So what else could it have been? All right, so let's think about how you dropped it. Well, each time you try to drop it from the same height. Did you drop it from the same height each time? No, that's why you got a range of short and long when you calculated the distances. So you should expect that your set of data should have a range of short and long. So you're not dropping it exactly the same place. That's called variation. But if you're consistently landing short, that could mean that you were, when you did your second set, and this would be a poor lab procedure, but you could be dropping it at a lower height every time, the second time around, and so therefore a lower height would give it a lower velocity or a slower speed across the table, and then it would be landing short. Another option, and you can look at this, just go back to your table, set the ball in there, see if the table's level. See if either the table is slanted toward or away. So it was causing the ball to speed up or slow down as it went up that or down that incline of your ramp. If it was slowing the ball down, maybe it could have caused 2 or 3. Or if it was sloped down and speeding the ball up, maybe it caused 4. Okay? So these are some possible situations. Now, what about 1 here? Okay? Group 1. Now, we only took 5 trials to get each of these sets of data. Okay? Some of their data landed below the average, some of their data landed above the average. Okay? What this means is their variation is very similar to the variation we originally started with. Now, because we only took 5 trials, maybe, oh, I just happen to have 3 trials that landed on this side, where before, when I did my timing, my 3 trials landed on the short side. You'll notice our average is slightly skewed down toward the short edge. So what this could mean is it's just variation, the natural variation of every drop that's causing that. How you would get number 1 to be more or a lower percent error is you could just do more trials. There was nothing wrong with how the lab went for this group number 1. It's just we only did 5 trials, and that variation is probably to blame for that percent error. Now, group 3, they landed in the range, but notice all of their dots are between the short and the average. Now, the chances are that we got 5 short ones in a row and we didn't get any long ones? There might be something else going on here that's causing it to land a little shorter. It skewed that data down just a little bit. So again, you can start to talk about things that might cause that. You can look at the edge of the table being rounded off. So even though you said the ball was going to make it to here before it started falling, it actually started falling back here, and so that caused it to fall a little short. Now, if you look at the curvature of the table, is that a lot of distance? No, but could it affect it? Yes. I want you to think about all the possible options. Don't go too extreme on me here, but give me some possible options and then link it to your data. The curve of the table means that the ball started to fall earlier than anticipated, so it would have fallen shorter. Okay, walk me through those steps. That's important. Okay, that's your write-up. If you have questions, please see me.